Once again, good morning. This is the lesson for Unit 5, Section 9. So we're learning 5.9 today. And let's just put right up front a list of the antiderivative formulas that we need before we call it a day. So before you walk out of here today, and you can just record this on a sheet of student supplied paper or a document, but we need to find the antiderivative of 1 over the square root of not 1 minus x squared, but more generally a squared minus x squared, although we'll make it even more generally, we'll go a squared minus u squared. So this is one of 3 formulas we need: square root of a squared minus u squared du. The second one is the antiderivative of 1 over a squared plus u squared du. First one's reminiscent of sine inverse. The second integrand is reminiscent, not exactly, but reminiscent of the derivative of tangent inverse. And the third one, even though it doesn't have an absolute value around the u, is reminiscent of the derivative of secant inverse. So in general, it's 1 over u without the absolute value times the square root of u squared minus a squared du. These are the big 3. And by the time you walk out of here, I think you'll be able to do some 5.9. All right, so I'm going to move forward through this document, and then every time we come up with a result, we'll cycle back to fill this in. Okay, by the way, for definitions, u represents a function of x, which is going to be a real valued function. Since we talk a lot about what symbols mean, both in movies and in math, let's be very careful here. Just like on the AP test, f of x represents a real valued function. And then a represents a real constant. A real non-zero constant. It's not a variable, it's a constant. And I just want to bring this down a little bit so these, okay, there we have it. So example 1. Actually, I have some notes to myself what I want example 1 to be. 6. This you don't have to write down. These are just notes to myself. I'm going to paste onto page 2. So I have them there. Okay, example 1. In example 1, we're going to take the antiderivative of 6 over the square root of 25 minus x squared. To find the antiderivative of this function, we recognize, first of all, that it has some similarities to the derivative of arc sine x. I mean, the derivative of arc sine x is 1 over the square root of 1 minus x squared. Because of those similarities, there's some hope that we might be able to doctor this up so that it has that in there. Here's our first move. First, bring the 6 out front so we really do have the 1 up top. And the second move is something that we're going to do simply because we do not yet have the formula. So this is kind of like derivation through example. So this is not what you'll actually be doing on the homework. What I'm going to do is I want to turn that into the number 1. So to turn 25 into 1, I'm going to divide it by 25. But that's not mathematically allowed. It's a doctoring up of the problem, unless I can somehow counterbalance that. So what I'm going to do is I'm going to divide the radicand, which means the stuff under the radical symbol, by 25. But to counterbalance that, I'm also going to multiply the radicand by 25. So I doctored and counterbalanced the radicand. So that was the first move. And as we see the details there, it doesn't have to be so big anymore. I can shrink it down a little bit. Now my next move is going to be to pull the square root of 25 out and write it as 5 times the square root of 1 minus x over 5 quantity squared dx. Look at the two things I did. One, I took the square root of a times b is the square root of a times the square root of b. The square root of 25 is 5. So the 25 has been liberated from the square root symbol. Now it's 5. Also, I noticed that x squared over 25 is the same thing as x over 5 quantity squared. This now has that characteristic derivative of sine inverse in it. As long as I make the following use substitution, I think that pulling the 5 out front, it passes through the semi-permeable membrane. I think we are looking at something that's just a minor use substitution away from a sine inverse derivative. That should be a 5. That's just the way that goes. It's unavoidable for software, the way it's set up, x over 5 quantity squared dx. Okay, so the use substitution that I'm now required to make is u is x over 5, in which case du will be 1/5 dx. So, I mean, I kind of had a 1/5, but this is technically what's going on. I need to put a 1/5 up top because I need 1/5 dx. So I doctor up the problem with a 1/5, counterbalance with a 5, which will always cancel out the other 5 that I brought out. So this is what happens every time, is that constant will cancel out front. So what we end up with is interestingly, is 6 times the antiderivative of 1 over the square root of 1 minus u squared du. So now it's clear that I can use sine inverse as the antiderivative function. So my answer is going to be 6 times the sine inverse of u, which, by the way, u is x over 5, plus a constant of integration. So that whole process can be shrunken down to no work whatsoever. I would expect you on the homework to do this problem without any work whatsoever. I would expect you to skip all the steps using the general result, which I would now like to have you flip back to page 1 and record. In general, when you see the antiderivative of 1 over the square root of a squared minus u squared, the answer is always going to be sine inverse of whatever u is divided by a plus a constant of integration minus u squared. So, let's put a box on that. Yeah. Now, let's find out then, knowing that formula, what would it actually look like on the homework? On the homework when you're doing this problem, and I will redo it. Here's problem 1, now that we know the formula. 25 minus x squared dx. So here, u is equal to x essentially. But here's how I'm going to do this on the homework. 6 comes out front. Sine inverse of square root of this, so let's put x over 5 plus c. That's the only work you're going to end up doing. That's why the homework's going to go so quickly tonight. It's a zero-step problem. It's simply writing down the answer. Do you have any questions as to what is going on here with problem 1? Okay, 1 down, 2 to go. Next. Going to copy in my notes so I know which example to do next. Okay. 10 over 36 plus x squared. All right, so here's example 2. What's the antiderivative of 10 over 36 plus x squared dx? I have a feeling you're going to be able to do this. Thinking of tangent inverse, with the derivative of tangent inverse in your mind, see if you can make appropriate doctorings and counterbalancings in order to find the antiderivative of this. Use the same kind of thinking that we did in example 1. Give it a go. Let's see what you come up with. Okay. Now I managed to get 10 over 36 out front. Times the antiderivative of 1 over 1 plus x over 6 quantity squared dx. Before I perform the u substitution, do you have any questions as to what has happened so far? Okay, so shrink that down a little bit and go to column 2. In column 2, well, I may as well let u equal x over 6. du is 1/6 dx. It is clear to me that I'm going to have to counterbalance, rather doctor this with a 1/6. I do need a 1/6 dx, so I doctor up to get that, and counterbalance with a 6 out front. Unlike last time where the 5 canceled with the 5, this time there's not a full cancellation, there's a partial cancellation. So it looks as though my next line is not 10 over 36, now we're down to 10 over 6 times the antiderivative of 1 over 1 plus u squared du. Okay, so again, the 10 is just along for the ride. And I think we're looking at tan inverse of u. By the way, u is x over 6. Plus a constant. So even though 10/6 reduces, I leave it in unreduced form just so you can kind of track where things came from. This is also a problem that I would expect you to do with no work. Simply write down the answer. But let's first of all record what we've discovered back on page 1. Take this back to page 1. What you see is that when you have, in general, the antiderivative of 1 over a squared plus u squared, part of it is going to be, just leave a little space here because there is a factor out front. Part of it's going to be tangent inverse or arctangent And oh, by the way, since I use these interchangeably on purpose because I remember one year I never wrote arc sine, I just wrote sine inverse every time. So then students got the AP test and they said, what was that arc sine thing? Oh. It's like, oops, yeah. So I'll use them both just to constantly remind you that things like arc tangent are the same thing as tangent inverse. Anyway, so this is going to be u over a plus c. There's one more piece. Instead of being just like the previous one, there's always going to be 1 over a out front. So we're going to be going from easy to hard. This is sine inverse is the easiest one to remember. Tangent inverse has one additional piece, and then secant inverse is going to have one additional piece beyond that. 2 down, 1 to go. Any questions on what just happened? Okay, let's now go to, just to emphasize, now that we know the formula, doing problem 2 again, here's what you'll be doing on the homework. 36 plus x squared. You're just going to pull the 10 out front, and then use the formula, which is 1 over a times tangent inverse of u over a plus c. Well, u, in this case, is x. So, 10, 6, 5/3. So, in the back of the book, the answer would be 5/3 tan inverse x over 6. Do you have any questions on example 2? Both the long way and the short way. Okay, here we go. Example 3, which I forget what I planned for example 3, so I'm just going to paste it into my document. And it's going to be 1 over x root of x squared minus 100. Okay, here we go. Example 3 is the antiderivative of 1 over x square root of x squared minus 100 dx. Notice there's no absolute value on the x. Okay. I'm just pointing out this is the original problem. This is what's given to you, and it does not contain an absolute value symbol. You don't need an absolute value symbol on the x to move forward with this. So this is the problem, and using a doctor and counterbalance approach to the problem, we want to turn that into the number 1, so it's going to be x squared over 100 minus 100 over 100. So I'm doctoring up the radicand in a way that's not surprising to you based on what's been happening so far today. I also have to multiply by 100. Okay, doctor and counterbalance on the radicand. So, oops, forgot the dx. So having completed that move, let's shrink this down a little bit so we have room to finish it up. So now, the square root of 100 is 10, so this comes out as 10x, which I could bring out all the way to here. I think I will. Square root of 100 is 10, brought all the way out front. We've got change my mind. I don't want to bring it all the way up front yet. I just want to bring it out to this location. No, that's not where it is. That's not where it is. Yep. I'm going back to what I had before. I'm bringing it all the way out front. Just working out some stuff in my mind. And I saw that this is exactly what I want to do. Okay, so we've got x over 10. Quantity squared minus 1. Just make sure we're okay with this position right here. It's all part of the derivation process. All right, so now I do want this expression to be the same as that expression. I do want to keep them the same. So I am going to do some additional doctoring here. I'm going to divide the denominator by 10, which means I also have to multiply the denominator by 10. This is all in the denominator. So now I have a total of 100 out front here, 1 over 100. But the reason I did that is because I want to make the u substitution as x over 10, in which case du will be a 10th dx. So I need 1/10 dx, just counterbalanced by a 10. So out front, the purple 10 will wipe out the green 10. It's predictable. Yeah, that's what I was working out in my head when I was deciding which direction I wanted to go. Okay. Fortunately, happily, you won't have to do any of this on the homework. This is essentially a derivation. And so now I think I can write 1/10 antiderivative of 1 over u square root of u squared minus 1 du. So it looks like, and again, absolute value is the splinter in your mind at this point. I'm going to show you where it pops in. But right now we've got 1/10 secant inverse of u, which is x over 10 plus c. The only additional move we have to make is we have to put an absolute value on the x. This is now the final answer, which in general, please flip back to page 1. Our general formula is going to be 1 over a, arcsecant, or secant inverse of absolute value of u over a plus the constant integration. So as you can see in this progression of formulas in today's lesson, 3 formulas, the first one's the simplest, it's just u over a. Second one is a u over a, except there's one more detail, which is a 1 over a out front. The third one has the u over a, the 1 over a out front, but the additional thing you have to remember is the absolute value symbol. All of them have plus e, so that's it. That's today's lesson. And you just have to practice it a little bit on the sum at 5.9. Just to confirm, now that we know the formula, if you were to encounter problem 3 on the homework, here's what you would do. If problem 3 were 1 over x squared of x squared minus 100 dx, you'd say, there it is. It's 1/10 secant inverse of x over 10 with an absolute value on the x plus c. You would do nothing more. You would spend no more time on this problem other than what it took to write down the answer. Okay? Do you have any questions on this? The final section of Unit 5. Yes, Edward.
Can I do that homework in class?
Well, we're doing something else in class. What we're going to do is continue our debrief of stuff that was missed on Deja Vu, the cumulative. Remember, we were going through and revisiting problems on which there was less than stellar levels of success. Let's try another one of these. Just need to grab my notes. I tallied up the results for every single problem so that we could enjoy this debriefing session. Do Do you enjoy debriefing cumulatives?
Yeah.
I kind of thought you did. Okay, so we debriefed numbers 3, 5, 7, and 9. 7 people in class missed problem 11. Problem 11 looked something like this. You know what I'd like you to do? I'd like you to just, in as detailed a manner as possible, try to build a mathematical case for what the value of k should be. For those of you viewing this in the luxury and comfort of your own home, in case you can't see it, it says the function f is continuous on the closed interval 0 to 6 has the values given in the table above. That's 0, 4, 2, k, 4, 8, and 6, 12. The trapezoidal approximation of the definite integral with 3 trapezoids is 52. So try to find the value of k. Your options are 2, 6, 7, 10, and 14. So I'm going to turn on the lights for a second. I'd like you to try to come to a conclusion as to what the value of k should be. Nice review of the trapezoid rule. Please feel free to collaborate as you're wrestling with this one. Okay, pair up with someone, see if you can come to an agreement as to what the answer is.
Oh, you don't.
Now, what I've done so far in this problem is just write down, according to my recollection, what the trapezoid rule is. B minus a over 2n times, again, this is the approximation of the integral, f of a plus 2 f of a plus b minus a over n keeps going, plus 2 times f of b minus, this is the second class term, b minus a over n. The last term doesn't have a 2 in front. The first term doesn't have a 2, last term doesn't have a 2. So if I were to apply that formula to this situation, I would take 6 minus 0 over 2 times 3, which is 6, times f of a, which is 4, plus 2 times f, basically the second number, which is k, plus 2 times 8 plus 12. And this expression set equal to 52 is what we need to solve for k. So this is why I think it's the best setup. This cancels. So as long as you can do the algebra 1, solve this for k, you should be good to go. By the way, what is the value of k? Or at least what's the solution to this equation? Matt, do you have it?
K equals 10.
K equals 10 is the correct answer. Do you have any questions on this one? Okay, so So that was missed by 7 people. There's only one other problem that was missed by 7 people. That was number 13. So let's talk through this together. For those of you viewing this from luxury and comfort of your own home, or maybe an airport somewhere, the problem is position, S of t. I told you, position is often represented by physicists with the letter S. Why? Why S? I don't know. I just noticed it. So S of t equals, I guess we're really talking about S prime. Would you please, just for fun, use the product rule to write out S prime of t. I don't know if this is how you did on the test, but S of t is t minus 1 cubed times 2t minus 7 quantity squared. Would you please use the product rule to write a formula for S prime of t? It's a lot of algebra. Go ahead, do the work. Write the derivative of position, which we'll understand to be velocity. I've done some preliminary work here. The narrative that's guiding my choices is derivative of the first times the second plus first times the derivative of the second, which requires careful application of the chain rule. Even though this looks scary, it's not too hard to simplify. Doing this without a calculator gives me although, you know what, as I take a look at this, I'm going to factor out a t minus 1 squared.
Times 2t minus 7.
And yeah, so in terms of the greatest common factor, there's a t minus 1 squared in both terms. Think of this as the first term, that's the second term. There's also a 2t minus 7 in both terms. So what remains when I factor those out is 2 times the quantity 2t minus 7, and over here is t minus 1 times, I guess that's a 4. So 4 times t minus 1. That's what remains in parentheses. I think it's a really good idea to simplify what's in parentheses to get velocity is t minus 1 squared times 2t minus 7 times, let's see if I can do this in my head. Well, maybe I don't really want to try that in my head. I think it's basically, I have to multiply 4t minus 14 by, oh, wait. No, I don't, that's complicating things for me. I don't want to distribute the 2. So I want to take 2 times 4 is 8. So it's 8 times, wait a second, did I really?
Plus, right?
Is it 2t minus 7? No, I factored out the 2t minus 7. So it's not really there anymore, right? Oh yeah, it was here. What I'm missing is the plus. I'm missing the plus, so there should be a plus right here.
Where'd the 3 go?
Right, we have to account for the 3. So it appears that the 3, 2t minus 7, could it be that when I wrote a 2 down here, I should have written a 3? Yeah, okay, let's fix that. Lots of details. So when I factor this out of the first term, what remains is 3 times 2t minus 7 plus, and then what remains from the second term after I factor out this is going to be a, yep, I'm just not happy with what I wrote for that. So in the first term, it was 3 times 2t minus 7 plus, and what remains in the second term is 4 times t minus 1. Because here's a 4, and there's a t minus 1. So are we okay with this expression now? When I simplify, this one I can simplify in my head. It's 6t plus 4t is 10t, and negative 21, negative 25. Okay, so now we can set up a number line, t, v of t, to finish the problem. We'll come back to this. I'm going to save the work that we've done so far. But have a good weekend. 5.9 is due on Monday. Quiz on Tuesday. You are dismissed.